Everyone, Mr. Fujita here, and I'm with Mr. Demelites, Mr. Nesas, and Mr. Baladad. And we are here to talk about chemical formula. Chemical formula is a way of expressing information about the proportions of atoms that constitute a particular chemical compound using a single line of chemical element symbols, numbers, and sometimes also other symbols such as parentheses, dashes, brackets, commas, and plus and minus signs. One of the types of the chemical formula are the empirical and molecular formula. Empirical formula tells you the simplest or most reduced ratio of elements in a compound, and molecular formula tells you how many atoms of each element are in a compound. So here's the structural formula of protein, and we are going to use it to find the molecular formula that will be discussed by Mr. Baladad.
Molecular formulas indicate the simple numbers of each type of atom in a molecule of a molecular substance. They are the same as empirical formulas, molecules that only have one atom of a particular type, but otherwise have larger numbers.
The answer for the molecular formula of protein is C4H10. We got C4H10. We just counted how many elements are there in the compound. 1, 2, 3, 4 carbons, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 nitrogens. So we got C4H10. Thank you, Mr. Baladad. And now we are going to find its empirical formula that will be discussed by Mr. Demelites.
The empirical formula of a chemical is a simple expression of the relative number of each type of atom or ratio of the elements in the compound.
That means the empirical formula of protein will be C2H5, because we will only find the ratio of the molecular formula of protein. Thank you, Mr. Demelites. And now, we are going to calculate why protein has C4H10 that will be discussed by Mr. Demelites.
Calculate on how protein has C4H10. Let's say that carbon has 48% and hydrogen has 10%. And let's also assume that 100% is equal to 100 grams. So what that means, carbon has 48 grams and hydrogen has 10 grams. Now, in order to get this, you have to divide it from its elemental mass. So carbon has 12 grams per moles. So that means we are going to divide it. Divided by 12 grams per mole is equal to 14 divided by 12 is equal to 4. And then cancel out the grams is equal, so that means it will be mole. Then for the hydrogen has a elemental mass of 1, meaning divided also divided by 1 is equal to 10. And also cancel it out, then it is going to be mole. Now, for the next step, try to find the least elemental mass of them all, then we are going to divide it there. So with this, the least elemental mass that has been used is 1, then we are going to divide both by 1. Both by 1. Is equal to 2. 4. And then. Meaning, for the carbon, we have C4, and then for the hydrogen, we have 8.
Thank you, Mr. Lineses. And now we are going to give another example where we are going to give the molecular and empirical formula of a compound by Mr. Demelites.
A sample was analyzed and found to contain 40% carbon, 6.71% hydrogen, and 53.29% oxygen. If the molecular weight of the compound is 180.16 grams per mole, what are the empirical and molecular formulas of the compound? To answer this problem, first we must convert the elements to grams. To do that, let's assume that the total mass is equal to 100 grams. With that, we can easily convert the percents to grams. Then, let's find the mole of each element. To do that, we must multiply it by its molar mass. For carbon, we have 1 mole over 12 grams. Hydrogen is 1 mole over 1.01 grams. Oxygen we have 1 mole over 16 grams. The answer for carbon is 3.33 mole. Hydrogen is 6.64 mole. And for oxygen is 3.33 mole. Now let's find the ratio of each element. To do that, we will simply divide each element to the smallest mole. The smallest mole we have is 33.33, so we will divide it to it. Now, for carbon we have 1, hydrogen we have 2, oxygen we have 1. Those ratios will help us find the empirical formula. For carbon we have 1C, and for hydrogen we have 2, so we're going to put 2, and for oxygen we have 1. And this is the empirical formula. Now we're going to find the molecular formula of this element. First, we're going to find the empirical weight of this element. The empirical weight for this element is 30 grams per mole. And we're going to divide 180.16 grams per mole and 30 grams per mole. The answer is 6. And then we will multiply 6 to the compound. The answer is C6, H12, and O6. And this will be our molecular formula.
So we hope that you have learned a lot from our brief tutorial about chemical formula. Thank you for watching.